Unit 4, Lesson 11 homework. Let's get right into it. We are trying to do 1026 divided by 27 using partial quotients. And it's going to be similar to Claire's strategy. I'm just showing you how the setup is going to be. Yesterday we used more of like an area model setup. Today we're going to use more of like the way that Claire used her partial quotients in class today. So let's get right into it. All right, so we got this number, 1026. We're trying to figure out how many times we can multiply 27. How many 27s can we fit into this number without going over? All right, that's basically what we're doing. So we want to take them out chunk by chunk. You don't got to get it all in one whop. So think about, let's do our powers of 10. All right, what would happen if we multiplied 27 times 10? And would that help us? 27 times 10, that would add a 0 to this. It would be 270. All right? So that would be 270 compared to 1026. That would help us. That would take out a piece. But let's think about it. Couldn't we take out, how many 270s do you think we could fit in here? So instead of just doing 27 times 10, maybe we could do, how about let's just start out with 27 times 20 and see what type of chunk that'll take out of our 1026. All right, so 27 times 20, 2 times 27 is 54, plus the 0 is 540. So that'll take out a nice little piece. Let's go ahead and subtract that. 1026 minus 540 equals 6. Oops. Hold on a second. Here. This turns into 10. Then turns into 9. So 8. All right. So now we got 486. That's how much we got left. All right, so do we have enough to take out another 20 piece? No, we do not. Because if we take out another 20 piece, it'll equal 540. That's too much. So let's just take out a 10 piece and see what that does for us. 27 times 10 equals what? 270. That's a nice little chunk we could take out. So y'all see exactly what we're doing? We're literally just kind of like, we're taking out piece by piece until we get to the part that we want to get to. So now we got 216 left. We're in a tricky position because we know with our powers of 10, 27 times 10 will give us 270. That's going to take out too much. That's too much. So we need to do less. Let's start with maybe maybe we could do a 5 piece. All right? Let's see, 27 times 5. And you might be thinking, that's kind of hard to do in my head. But you do know that 27 times 10 is 270. How about we just divide that by 2? And when we do, give us 135. Okay, so now we'll take that piece out. So we're getting closer and closer. All right, so now we got 81 left. How many 27s can we fit into 81 without going over? And hopefully you'll be telling me 3 because you're knowing that, yeah. Yeah, 27 times 2 is 54. Then you add another 3, that's 81. But even if you didn't know that, you could take out a piece. You could take out a 2 piece and get there. But I'm just going to go ahead and do it. 27 times 3 equals 81. Okay, so the coolest thing about partial quotients is you could take small pieces, you could take large pieces. Like the first thing we did was we could have took out just 27 times 10, but we knew, how about we just take out a 20 piece at the start? Okay, yeah, all right, let's go to the next one. And y'all be patient because I know this is our second day kind of dealing with partial quotients. So like the terminology that I'm using, like when I think about taking out pieces and stuff, the thing about partial quotients that I really love is like you all are gonna show me your answers like tomorrow, and you all might have solved it. You all use the same strategies, but the same mode of thinking might be different. I might have people that are going to be able to take out big chunks out of there. And then I got people who are just going to want to go, hey, let's take out the regular, just 10 by 10 by 10 until I get to where I get. None of y'all is wrong. All right? That's the dope thing. There's so much, not to say room, but there's so much when it comes to partial quotients. There's a lot of freedom. That's the way I like to look at it. So now this next problem, 814 divided by 37. I'm going to set up my... I'm tripping already. I'm gonna put my 37 over here, so I got like a lot of room to work with. And then I'll put my 814 over here, because this is where I'll be doing my subtraction for when I take out the chunks from over here. So now let's think about it. If we're dealing with powers of 10, 37 times 10 equals how much? 370. That's a nice little chunk we could take out. But don't you think we could fit even more in that? I think we could, because 370, if we rounded, we could round 370 to like 400. And if we take two of those, it'll equal 800. So I say all that to say this. We could just take out a 10 piece, but go ahead, let's double that. Let's take out a 20 piece and see where it takes us. 37 times 20, 2 times 37 is 74, and then add your 0, so it's 740. Okay? Now, we'll subtract that. Yeah, 4, 7, it's going to be 74. So now what we got left? We got 74 because we took out that big chunk at first. All right? And like I said, guys, do with what you feel comfortable with. If you feel only comfortable taking out 37 times 10 first and going from there, that's fine too. It's perfect. Nothing is wrong. It's like you're cutting down this big tree, and the axe is whatever size you want to make it. Okay? But let's talk about it. Now we got 74 left. How many times will 37 go into 74? If you're thinking 2, you're right. Because 37 times 2 equals 74. 74 minus 74 equals 0. So our answer is 22. And I hope I taught the same structure and procedures. Calculate 456 divided by 19. And then the last problem, calculate 592 divided by 16. What I'm looking for is tomorrow when I want you to see your structure. I want to see that you've subtracted the chunks that you're doing. And, yep,